Go ahead.
Wait, what can I do?
Go online to Google Classroom after 1:45 p.m.
Okay.
All right, so let's go ahead and get started. I am recording, I believe, at this time, so I do need your full attention. Pay careful attention because what we're doing today, like I said, we're going to do what we call advanced stoichiometry.
Wow.
Or stoichiometry continued. So, in the first lesson on stoichiometry, we learned the basics. How to convert moles of any reactant to moles of any product, moles of product to reactant, moles of reactant to another reactant, all using the moles of A to moles of B strategy. We also learned how to change grams of any reactant to grams of any product using the grams to grams strategy. But are there other units that exist outside of moles and grams that you could be asked to convert? Yes!
Oh.
And so this is the stoichiometry map that will help guide you through all the different types of conversions you could be asked. So what am I really trying to tell you here? It's not always as simple as moles to moles. What if I gave you liters
Don't do that.
at STP
Don't do that.
and I asked you for molecules? Could we of something else? We could do that because you could change the volume in liters to moles. Then you could change moles of whatever you have to moles of what you're looking for. Then once you have moles of what you're looking for, you can convert it into always grams or particles or volume. So this is like the chart you got back in lesson 2, but doubled for the idea that you now have moles of A that can be converted into moles of B. That's why I said you're going to want to track along for this lesson. So this stoichiometry map addresses what if I'm given a different substance than the one I'm starting with, and what if the units are not in moles? Okay? So the concept is, if you are given a different unit than moles, than moles to start, so your A is in a different unit, the first step is always going to have to be to convert to moles. Notice all these arrows go to the same place. They all go to moles. Step 1 would always be to convert to moles. So convert to moles. Yes, all roads lead to moles. All roads lead to moles. All paths lead to moles. Then once you have moles of your given substance, then you can convert to moles of your asked for substance, and that's what we call stoichiometry, going from moles of A to moles of B. That's stoichiometry.
Yeah.
That's the bridge to get from the thing you start with to what you're looking for. So whenever you're switching substances, you use stoichiometry to do that. And then you have moles of B, but what if you weren't asked for moles of B? You could, instead of being asked for moles, you could be asked for grams, which we already discussed last class how to do that. You could be asked for atoms, molecules, formula units, ions.
Say that. I'll say that.
Or you could be asked for volume at STP. So if I need to get out of moles and I need to go to grams, you know you have to use the molar mass, right? If I need to get out of moles and I need to get to particles, I need to use a specific number that I do suggest that you remember for the test called Avogadro's number, 6.02 times 10 to the 23rd. And if I'm going to volume, I'm going to need to use that number 22.4 to get there. So the idea is that if I'm asked for a different unit, that's probably the call, then moles. Hello, this is Liz Lee. Okay, no problem. All right, Sophia, you are receiving homework.
Wait, I got one of the homework.
Oh, is it the right one? Okay, then I gave it to you in anticipation.
Yes, yes.
All right, there's only one homework today. That's the good news. If I'm asked for a different unit than moles, I have to convert out. Or if you are, convert from moles.
I'm not right.
Wait, can you do this?
Well, I'm sure I'm here. But take a picture of the stuff that you don't write down.
He's out here.
I should have it now.
Okay, so concept. If I have mass and I want to get to moles, I always have to use the molar mass. Would that be a division or a multiplication? It tells you here. If I want to go from mass to moles, would I be dividing or multiplying by the molar mass? It's divided, right? If I want to go from particles to moles, I also divide by Avogadro's number. And if I want to go from volume to moles, I divide by 22.4. That's the conversion.
So when you're going to
2 moles, you would be dividing by one of those numbers.
out of moles,
You multiply. Yeah.
Thank you for.
You're welcome. All right. And when I'm going from moles to mass or moles to particles or moles to volume, notice that the numbers are all on the top. So I would be multiplying by liters. If I'm looking for liters, I'd be multiplying by 22.4. I'd be multiplying by Avogadro's if it's particles. And I'd be multiplying by the molar mass if I'm going to grams. And so today, we're going to look at questions that go through some of these different pathways. I'm not going to do a question on every single pathway that exists because the expectation is given this knowledge, you can do any of these conversions. All possibilities are on the table. So that means today we're covering 2-step questions and we're covering 3-step questions. That's what we're looking at. Last class we only did 1-step questions.
Sitting in the middle for a natural.
All right, so here we go. Mixed moles to grams questions. And you'll notice this whole lesson is basically practice questions. Just how do we integrate lesson 2 with lesson 4? And so mixed moles to grams questions, question 1 out of 5 that we're going to cover today together. N2 plus 3H2 goes to 2H3. What is this called? A balanced equation. For those of you that weren't here last class, will the equations be balanced on your exam?
Yes, except for maybe in the extra credit.
Yes,
On the 100% part.
except maybe the extra credit.
Except maybe the extra.
I haven't written it yet.
I'll decide how I feel.
See you over the weekend.
Hopefully you feel nice enough to get us balanced.
So this is for the test. I will. I said I haven't written it yet, so I haven't written the extra credit. But maybe not. So questions on the board. We've got a balanced equation. The question says, how many grams of H2, so you should underline that because that's being asked for, are required to react with 0.35 moles of N2? So the first thing you're going to want to do is make a pathway. You'll recall this terminology when I was teaching you lesson 1 and 2 this unit. I said the first thing we should do is make a pathway. This is a thought process. How do we get from where we start to where we end? I also said that technically you could do the thought process in your head. If you're good with that, you can do that. I'm going to write the thought process out because I think that's important. But like if you were showing work on an exam, you don't have to show how to make the pathway, but I'm going to go ahead and show it now. So first step is make the pathway before we start solving the question. What do I mean by that?
I have to go.
You should write the units of the number you're given and the units of what you're being asked for. So what am I being given here? What's the number I'm being given? What are the units of that? Moles of N2. And N2 is my A. Would you agree? Because that's what I'm being given a number for. So I'm starting at moles of N2. What am I being asked for in this question? That's important. What are you being asked for and what are you being given? What am I being asked for?
Oh, we're being asked for grams of H.
Grams of H2. So this is my B. Because I'm being given a different substance than the one I'm being asked about, I have to use stoichiometry to switch between substances. So what do you think your first step should be? And if you need a crutch for now, you can go back to the guide here. Will this be given on the test? No. Just like the other mole map was not given on the test, this will not be given on the test either because Cambridge ain't given it, so I'm not either. They expect you to be able to make these connections in your brain to go how to get to moles, how to switch over to a different amount, and then how to switch out. So this is expected for you to know. You can either memorize the chart or just know how to do the pathways. So how do I get from moles of N2 to grams of H2? N2 is A and H2 is B. So what would I do first? What's my path? Moles of A to moles of B. And then moles of B to mass using the molar mass. So our missing link, our second step, is to go to moles of H2. And that then can get us to grams of H2. So this is going to be 2 steps. Welcome back. Next up for the bathroom. You had asked now?
Yeah.
Okay, sketch on. All right.
And it's 03/012, 1:25 p.m. There you go. Yep.
Okay, so let's continue. We have moles of nitrogen right now. We need to get to moles of hydrogen. What's the process? How do we go from moles of one thing to moles of another? It's called stoichiometry. Right? What we learned last class. How to go from moles of one thing to moles of another. And I gave you a formula for that. Then, how do I go from moles of hydrogen to grams of hydrogen? What do we do to go from moles to grams? Moles to grams. Molar mass. So this right here requires us to get the molar mass. So now we've went through the thought process. We know what we got to do. We just got to go solve the question. So solve the question. Start by writing what to solve the question? The number that's
First in the
given, right? So we start by writing 0.354 moles of N2 over 1 multiplied by line. We got to figure out our A and our B. We've already identified it. A is N2, that's my A, and B is H2. So using my balanced chemical equation, these are moles, right? So I can just pull these numbers for my conversion. What numbers should go on the bottom? 1 or 3?
1.
1, because the N2 has to go on the bottom. It has to match 1 mole N2. And what number goes on the top?
3.
3. Now at this point, it is your decision if you want to stop here, get this answer, and then do step 2, or just go add another conversion factor. Either way, you'll get the right answer. I'm going to show you both ways. So the first one I'm going to show you is just going to do the second step now. So if I go to do the second step now, I would need the molar mass. Do I multiply it or divide by it? Do you remember?
You multiply.
Multiply by it. And the actual reason why is because 1 mole of H2, which would cancel on the bottom, is 2 grams of H2, which would be on the top. And that would give you this. And you get your answer, which is 0.354 times 3 times 2. And the answer is 2.12 grams of H2. That's your final answer here. How else could we have done this?
Wait.
Alternative way. After the first step, you could have done this. 354 moles of N2 over
We
1.
go to 3 seconds, right?
Yes. 3 moles H2 over 1 mole N2. So I said you could stop here technically. 0.354 times 3 and get 1.062 moles of H2 and then just multiply by the molar mass because moles times molar mass is grams. And so that would give you 2.12 as well. Either method would give you the right answer. This is doing it in 2 steps, and then this is doing it all in 1 line. What do most people use that actually move on to STEM majors in university, and how do all university professors teach it? The top way. Is Cambridge okay with accepting the bottom way? Yes. Cambridge just needs to know what you multiplied by, what you divided by, and it has to make sense, like whatever relationship that you're making. So either way is fine. You pick whichever one you will prefer to do. I'm giving you options. What's my preferred method? Well, now I think once you get good at this method, you want to do it because the thing about the method at the top is that there's less rounding errors. Because if you're doing all your multiplications at once instead of stopping, writing a number, and multiplying again, every time you stop, round, and multiply again, you introduce something called a possible rounding error. So we knew that we had some rounding errors sometimes in empirical formulas. Like that's where you could really get into trouble with rounding errors. You gotta be careful with it. But this is the concept. This is what you do. You ready to see another one? 2 steps. Next 2-step question. All right, same balanced equation, but now we're being asked for something else and given something else. Oh boy, how many liters of NH3 are produced at STP? Should that STP abbreviation mean anything to us?
Standard temperature and pressure.
Standard temperature and pressure. And it's our clue that we should be using this. Like that's our clue. You should be using that.
Are they ever?
Because that's the liters at STPs. Who's they? Cambridge?
Yeah.
Are they ever gonna what? Complete the thought?
Are they ever gonna ask us for something like this?
Not at STP?
Not an STP.
Yes, that's called the ideal gas equation.
Is that gonna be for our?
That would
class?
be not in the pre-ACE curriculum.
Perfect.
That's
All I care
in the
about.
ACE curriculum.
Thank you.
So
not a
at
problem.
non-standard temperatures is something addressed, but not in this course.
So
Today we are only, or this course, we are only looking at standard temperature and pressure.
it's not a problem. It's perfect.
Not a problem at the moment. All right, so this is what we're looking for. How many liters of NH3 gas? That's our question, right? At STP, so that means we know we're gonna have to use this number. When 0.56 moles of H2 react with excess N2 in this chemical reaction, do we care about the word excess? No. It means that there's plenty of it in the reaction, and if that confuses you, you can see like cross it out. Like if that confuses you, just cross it out. You don't need that at all because it means you have plenty. You have extra N2. You are limited by the amount of H2. So, what's our A and what's our B? What I have a number for, that substance is my
Moles of H.
A. So this is my A. And what's my B?
Liters of H.
NH3 is my B. Because I'm looking for NH3. That's what we call our A and our B. Welcome back. So, make a pathway. Make a pathway. Remember, this is the thought process. This is how we're going to get from where we start to where we end. Where are we starting? In this question.
Moles of H2.
Moles of H2. And where do we seek to get to?
We want to get to the liters of
Liters of
NH3.
NH3. H2 and NH3, would you agree they're not the same thing? Hydrogen is an explosive gas. We tested that when we used a wood splint to test it in a mini explosion in a test tube. Whereas NH3 is ammonia, which is used as a household cleaner.
I would hope it
Maybe
wasn't
familiar with it. No, it is not itself explosive, but it can be dangerous when mixed with certain other chemicals, which is why you should never mix your kitchen cleaners together.
Yeah, because you would.
All right, so they're not the same thing. We agree. Which means we have to use stoichiometry to switch from hydrogen to NH3. And you should use a moles to moles conversion to do so. In the process of stoichiometry, it should be moles of H2 goes to moles of NH3. And then once I have moles of NH3, my substance B, now I have to change it to liters. This is stoichiometry. And this is what? To go from moles to liters. We know we're gonna have to use 22.4, right? That's the key number for liters. So then let's solve the question. And by the way, this pathway would it also be found here? Moles to liters. Moles of A goes to moles of B first, and then moles goes to liters. That gives you the order of what to do. All right, so now here we go. We write 0.560 moles of H2 because you always start by writing the number given in the actual question. Then step 1 here, stoichiometry. So we're going to put 1 on the top and 1 on the bottom. 3 and 2 are the numbers we choose. What number goes on the bottom? 3, because it has to match with the H2, right? 3 moles of H2 on the bottom, and how many moles of NH3 on the top? 2 moles of NH3 on the top. Now you have a choice. You can either stop here, get this answer, and then do step 2, or you can do it all in one line. I'm gonna once again show both ways. So the first way, which is what I would do, is say, okay, 1 mole of NH3 is 22.4 liters. Multiply and divide and get your answer. So 0.560 times 2 times 22.4 and divide that by 3. I get 8.36 liters NH3. And what would be the alt way to solve? You can do the stoichiometry first, if you prefer this. Get the answer to the stoichiometry. Which would be 0.373 moles NH3. And then say, okay, I have moles, I want liters. To get to liters, I just know I have to multiply by 22.4. So just remember, oh, that's times 22.4, because I'm trying to get to liters, and it will give you the same answer, 8.36 liters NH3. Either of those two methods, like I said, for most scientists, the top one's the preferred way, but if that's a struggle for you, you can do it the bottom way and it's okay. I'll pause. The next one is molecules. Everybody's favorite, right? Molecules?
Hey,
Figuring out molecules?
I love molecules. I'm so happy.
All right, so the next question is going to be our last 2-step one. Then the other 2 we're going to, well, the one after that will be a 3-step question, so you can see a 3-step question, what that would look like. All right, ready? Yes.
Ready if we're gonna go.
Okay, let's do it. Last 2-step question. How many molecules of NH3 are produced when 0.56 moles of H2 react with excess N2? So we're looking for molecules, and we're being given H2, and we don't care about the N2 because it's an excess, right? So what's our pathway here? Where do we start? We are once again starting with the moles. Moles of H2. And this time we're looking for molecules, which no, you cannot shorten, of NH3. Can we go directly there in one step? The answer is no. Because you first have to switch out of hydrogen into the compound you are looking for. So you have to do stoichiometry first. So you go moles of H2 to moles of NH3. And then once you have moles of NH3, then you find the molecules of the same thing. So 2 steps again. For the first step, it's stoichiometry. And the second step to go from moles of molecules, what's that number that we should be thinking of in our head? 6.02 times 10 to the 23rd should be the number in your brain, right? That's what you should be associating with molecules, with atoms, with ions, and with formula units. So let's solve the question. To solve, start with the 0.560 moles of H2 over 1. Multiply by what goes on the bottom and what goes on the top. What's my A and what's my B? H2 is my starting, so that's my A or B? A. And what I'm looking for is my B. I'm looking for NH3. So NH3 is my B. So I pull those numbers for my conversion. So what goes on the bottom? So 3, right? And NH3, the 2 goes on the top. I'm going to go ahead and do the next step in one line. So what would the next step be to get to molecules? Do I multiply or divide by Avogadro's number? And that's really the most important question, whether you multiply or divide. It is multiply. Multiply, because I'm looking for molecules. I have to multiply by Avogadro's number. It's 6.02 times 10 to the 23rd molecules in 1 mole of NH3. So I said, it's usually better to set it up so that you remember what to do. So it's 0.560 times 2 times 6.02 times 10 to the 23rd for the top, which gives me 6.74 times 10 to the 23rd over 3. Divide those two, and I get 2.25 times 10 to the 23rd molecules. For those of you who do not want to use dimensional analysis, you would still have to do it for the stoichiometry, for the first part. So 0.560 alternatively. 0.560 moles of H2 over 1 times 3 on the bottom, 2 on the top, to get the ratio, we call that. And then you would get the answer there. Okay, you get the answer there. That answer would be in moles. So 0.560 times 2 divided by 3. So 0.373 moles of NH3. And then in order to do this, you'd say, okay, so I know that's the moles. I want to get to molecules. There's always more molecules than moles. So if I'm switching out of moles, I'm always multiplying. And it would be times 6.02 times 10 to the 23rd, essentially giving you the same answer of 2.25 times 10 to the 23rd molecules. You can use either of these two methods. They are both appropriate. That's it. Before I move on, could you have realized that you made a grave mistake if you had divided by 6.02 times 10 to the 23rd instead of multiplying?
Yeah.
And why would you realize you've made a grave mistake?
Because you would get a number that didn't make any sense.
You would get, if we took 0.373, right? And we divided that by 6.02 times 10 to the 23rd, assuming that you divided correctly, and you didn't make another mistake. You would get, like if you had divided instead, if you had divided, which is wrong, to be clear, you would get 6.19 or 6.2 times 10 to the negative 25 molecules. Why is that wrong?
Because you can have negative moles.
You would be saying that you have 0.0000000000000621 molecule.
It's not a lot.
Okay, so just saying, this is, for example, 1 molecule. This is one molecule. Can you have 0.0000000 of a molecule?
It's like the line of the H. That's all you get.
It's like saying, because remember, when we're counting amounts, it's like counting objects or counting species.
You actually just have that one electrons. That's it.
You either have a molecule or you don't have a molecule. You cannot have a fraction of a molecule. The smallest amount of molecules you can have is
What?
1. If you get an answer less than 1, you did it wrong. Maybe instead of dividing, try multiplying. Just as a clue.
Heads up, don't be stupid.
So if you get that as an answer for an amount of molecules, if people got on the last quiz and left it like that,
You're so right.
wrong.
Nobel Prize right now in your mailbox.
Molecule
Serial number
equal 1. You cannot have less than 1. So if you said
say bosses no.
at your next test that you have 0.5 molecules of water. No, you don't. No, you don't.
So 10 to the
So,
negative 25 power is
Just
7.
throwing that out there is, you know, when you're getting your answers, it would be helpful to see that they make sense. Like your answers should make sense. Anyway, just an aside that I think was important because when you get answers, they should make sense. Molecules should be a very large amount in comparison to the amount of moles or grams or liters. Molecules should be a lot. All right, this next question, I realized in the last class. Yeah, sure. Sure. No less than one molecule, no less than one atom, no less than one formula unit, and no less than one ion.
Less than 1 gram is possible.
Less than 1 gram is possible, yes.
Go ahead and get less than 1.
That's fine.
Just don't get less than
But
1.
not less than one of an object. You have it or you don't have it. Okay, so practice reaction 2. This is a different reaction. I actually want to change this up. I changed it up in the last class. Because right now this is only 2 steps and I need to show you 3 steps, don't I? So let's change this to molecules, of course. How many molecules? Change that to molecules. So we can make it 3 steps instead of 2. How many molecules of water are produced when 63.3 grams of butane reacts with excess oxygen? Remember, excess means you can delete that for your brain. You don't need to use that in the question at all. All right, so 3 steps. Let's see what we do. Make a pathway. Pathway. What are we starting with this time?
Molecule.
Nope.
Oh, no. This looks
Grams, right? So we're starting with grams of C4H10. And what are we seeking? What do we seek to find?
How many moles?
I changed it. It's molecules of H2O. Because I want it to be 3 steps. I want it to be 3 steps. Because you need to see 3 steps. So I want to go from grams of C4H10 to molecules of H2O. So the way that I advise to go there is to change 2 moles first. Remember what we said in the beginning? If you're not in moles, you should change to moles first. So change grams of C4H10 to moles of C4H10. And in order to do that, we would get the molar mass.
And then we need to go to moles of
Then we got to switch from C4H10 to what we're seeking, which is water. So moles of C4H10 to moles of water. And in order to do that, we do stoichiometry or stoich.
then we do molecules.
Then we can go from moles of water to molecules of water using Avogadro's number. 6.02 times 10 to the 23rd.
Maybe I'm a god for sure before you do the cuts.
So now that I've laid out the process, we got to go solve it. So let's solve the question. Solve. Method 1. And remember, I will give you an alternative afterwards. So method 1 is the one that most scientists would use. Start by writing your given, 63.3 G C4H10, and any STEM major, anybody, if you're going to go take a chemistry class in university at some time, they require you in your labs to write your work in this way, actually, most people. And how would we do the molar mass? Would we multiply it or divide by it? Grams are on the top, so grams have to go on the bottom. It's got to be division. So what is the molar mass of C4H10? We have to find that out. What is it?
74.
Right. 58. How do we get it? 4 times 12, you might have done 16.
Yeah, I did 16.
Plus 10. 4 times 12 is 48. 10 more, 58. So 58 grams of C4H10 go on the bottom, and 1 mole of C4H10 goes on the top. That gets us step 1. But now we got to get out of C4H10 and get into water. So we need step 2, stoichiometry. What's my A and what's my B?
Your A is
What we start with,
and then your
and our
B
B is here. So now we go to the equation and find our A, because stoichiometry requires you to use the balanced chemical reaction. And we find our B. A and B. So what goes on the bottom, what goes on the top for your balanced equation for our stoichiometry?
1 mole of C4H10,
Because that comes from there,
and then 5 mole of
because that comes from there. That's the conversion. That's our step 2, but that gets us here. We still need to get the molecules. So how do we get the molecules?
we gotta do it the record.
1 mole water is Avogadro's number, molecules, multiplied by the molecules. And so that would get us our final answer, which if you get it right, you can check your work to see if your method matches. Divide by 58. I get 3.29 times 10 to the 24th power of molecules of water. So if you're not good with doing dimensional analysis the whole way through, what would be your method? You would start by doing maybe your little triangle to do G mole mm. You're trying to get to moles, so you would do G divided by mm. And so you would do 63.3 divided by 58 as step 1, and you would get 1.09 moles of C4H10. C4H10. Then after you get the moles, you would still have to do stoichiometry to get from C4H10 to water, right? So you would then say, okay, that's 1, and 1 mole of C4H10 is 5 moles of water. So you would essentially do 1.09 times 5, and you would get 5.46 moles of water. And then you'd say, okay, but I'm not looking for moles, I'm looking for molecules. So I'd have to know to take this and multiply by Avogadro's number. 6.02 times 10 to the 23rd. This breaks all 3 steps up, basically, into the individual steps. You can do it this way. It's actually more work, in my opinion, but you can do it this way. And you would get the same answer, 3.29 times 10 to the 24th. If you have your own unique method, just make sure you come up with the right answer every time. If it doesn't work once, then your method's not good. Go ahead, scan, show, and go. Some common questions I receive from students include, Miss, instead of going from, in this question, from moles to moles, could I have instead went from grams to grams? Could you have? Like using the other methods that we learned last class, instead of going from moles to moles, we went from grams to grams.
I don't think so.
Technically, yes. Because last class I taught you how to go from grams to grams directly, right? As a shortcut. Because according to what we learned here today, to go from grams to grams, you technically should take 3 steps, but I taught you how to do it in 1. Why did I teach you how to do grams to grams in 1 step instead of taking all 3? Because it's the most common conversion asked. And I didn't want you to have to do 3 steps all the time. So that's why I taught you a shortcut method to go from grams of A to grams of B, using what I gave you at the beginning of class today and also last class. However, if you use that method, like some people suggested and have been doing in some of the other classes, starting from grams of A to grams of B. Well, then you still have to go from grams of B to moles of B, and then from moles of B to particles. So you're not actually saving any steps, and I think you're doing more work, actually.
Yeah,
Because that to that, that to that, that to that. It should give you the same answer, but I think it's more work.
Yeah, wouldn't it just give you more work to do?
It would, but several people, especially in the BT classes, have been doing that.
I guess
Like, that's why I said if you have a method and it works for you, do it, but just make sure it works every time. Otherwise, not great choice. Pick something else to do.
Take another method.
All right, final question that we're gonna do together today is actually grams to grams.
Oh, just take a long time.
And it doesn't have to, does it? Because although it says according to my map, you can do it in 3 steps, I taught you how to do it in 1 step. So I'd rather you do it the way that I taught you to last class. Do it as a grams of A to grams of B question, like we learned before. You just have to identify what you're looking for. This is my B. And what you have. This is my A. So then remember, if I'm doing grams to grams, I have a problem with my equation. My problem is that these amounts are not grams. These amounts are moles. So I would need to change these amounts, this relationship from moles into the corresponding amount of grams. And how do we do that again? We take the molar mass and multiply by the moles. The moles are in the front. The great thing about this specific question that I didn't realize when I wrote it, or I didn't think about, should have, is that the moles here is how many? 1. The moles here is how many? 1. So literally the molar masses is all you need to solve this question. So grams to grams, start by getting your molar masses of barium hydroxide and of barium chloride. So barium hydroxide would be 137.3.
The whole thing.
No, that's barium. 32 for the oxygen and 2 for the hydrogen. Do you understand how I pulled 32 for oxygen?
Yes.
There's 1 oxygen here, but there's 2 on the outside. So there's a total of 2 oxygens, and you multiply that times oxygen's molar mass of the periodic table of 16. You are expected to be able to get molar masses pretty quickly at this time. We've been doing it for a month at least. And you are allowed to use your calculator for it. 171.3 is the molar mass here. Barium chloride, the numbers would be 137.3 plus 71. Where do I get 71 from? Chlorine on the periodic table is 35.5. I do not expect you to memorize that, but I expect you to be able to pull that off the periodic table. 35.5 times 2 is 71.
I feel like after enough time, you start to memorize the really common ones. Like the really common ones, you just start to.
That's why when students ask me if I know atomic acid masses, I say if it's a common element, yes, because I use them all the time. So I'm not even looking at the periodic table half the time when I'm writing it down. All right, so that's our mass of barium chloride. So how do we solve? Start with writing our starting amount, which is 55.9 grams of BaOH2 over 1. What number goes on the top? What number goes on the bottom? A goes on the bottom, barium hydroxide, which what number is that? In grams, the grams relationship is 171.3 goes on the bottom. And what goes on the top? 208.3.
Here you go. Right faster.
Then multiply and divide, and you have your answer. So it'd be 55.9 times 208.3 divided by 171.3, and you get 68.0 grams of barium chloride. You could solve this in 3 steps, but I do think that it's more optimal, efficient, if you did it in 1 step. All right, so I'm going to stop recording now and then bring up what the important question or vote you have